Okay, so for those of you who weren't here yesterday, my hope is that you've been able to go to the website. If not, if you go right over here to the filing folder, the notes that I passed out yesterday over composition are there. I'll see if I can get you caught up as soon as possible. But I want to continue with this today. We also got a homework assignment yesterday that's going to be due tomorrow. Now, don't forget, next week, Friday, is the end of the 6 weeks. So if anybody is really concerned about your grade, we only have a limited opportunity to go ahead and do anything about it. Okay, please come see me sooner rather than later. And I say that because what's happening on Monday? Monday is your test. Okay, so it's going to cover 2 topics. It's going to have the graphing and analyzing rational functions. So finding me the asymptotes, the holes, intercepts, all that good stuff. And it's also going to have composition of functions on there as well. All right, and I believe, yes, I also have, I don't think I took care of that yet, a couple of focus activities for the folks who weren't here yesterday. If you haven't already grabbed one of those, let's see. Brandon, did you grab the one has the girl with the umbrella? Okay, so you got that? Okay, Nathaniel, did you grab one too? Okay, so we're good to go on that. And then the rest of that was Trey. Okay, so we're good. Excellent, excellent, excellent. Okay. Other than that, yes, sir. I'm sorry? The one that had the 2 columns on the front were in the middle. You were going to go ahead. At the very top, it had a table. It had a function. This one right here, no, I believe that's the nose. Yes, the homework looks like this. It's the paper that you picked up yesterday? Yes, sir. Okay. So it only has 10 questions on there. This is the homework you got yesterday? Okay, it's going to be due tomorrow. Due tomorrow. There we go. Thank you, Marcus. All right. Cool. And also, because the end of the 6 weeks is coming up, in certain classes, you have to take a what? The district assessment. So that is coming up next Friday. In here, we still have to go ahead and take it. It's 20 questions, multiple choice, so it's not going to be horrible. Okay, and I'm going to go ahead and curve the grades as well. But that will be the last item that we have for the 6 weeks. And I've got it scheduled next Friday, because I want to go ahead and spend the majority of our time talking about inverses of functions next week. And then after that, we should finally be done with the review, and we can get into trig, which is what, the majority of pre-calculus is going to be about. All right, so are there any questions, anything? No? Okay. Remember, if you're having difficulty, please come on in and talk to me. I can help you out. If Miss Landry is here, she is more than willing to help you out. Yes, Andrea.
Are we going to be able to use our notes on the assessment or the exam?
Now, the exam on Monday, I'm going to let you use your notes. Okay. As far as the district assessment goes, it's not my exam, so I would be perfectly fine with that. I'd be perfectly fine with you doing that. And it's multiple choice, remember, so don't sweat the district assessment. Okay, I am not concerned with that at all. I'm more concerned with the test on Monday, and that you may use your notes. Yes. Yes, ma'am. No, ma'am, we don't have an end of course. No. All right, so let's see. We've been talking about compositions of functions, and yesterday we went through a table. We went through the graphs here, and I believe we got right about to the equations. Is that right? I don't think we got here, so let me erase that. Okay. Didn't we do at least the first one? I think. Okay. So a lot of people are saying yes. Christian is saying no. Okay, so maybe we can take a look at our notes and find out. Now, number 2 is not a composition of functions. Now, what am I referring to when I say a composition of functions? Remember, we're talking about evaluating one function inside of another. Okay, many times I said the output, the y value for your inside function, okay, becomes the input, the x value for your next function. Okay, so let's take a look at number 2. Now, while this is not a composition of functions, it is at least a little bit of review when it comes to function notation. So we've got 4 functions here, f, g, h, and p. So we'll know exactly what equation we need to go ahead and substitute into. All right, so like f of negative 2. All right, so here's function f right here. So I want to replace every x with that negative 2. All right, so let's see what that is. F of negative 2, so negative x squared. So that's negative 2 squared. Remember, you're only replacing the x. Everything else remains the same, plus 3x. So plus 3 times negative 2, and then minus 5. Okay. Very cool. Ma'am, do you have your notes?
Yeah.
Okay. All right. So help me out here. Negative 2 squared. Okay. Now, it would be positive 4, but you're right. With the negative outside, this would become negative 4. And then we have plus 3 times negative 2, so that's a minus 6. And then we have the minus 5. So that's going to give me a negative what? Negative 15. Perfect. Okay. So we got that taken care of. Now let's go ahead and take a look at P of 2. So this time I'm going to switch equations. Now we're on function P. Every x I'm going to replace with 2. Okay. So instead of x plus 2, I'm going to say 2 plus 2 over x minus 3, so 2 minus 3. So it looks like I'm going to have a 4 over what? Negative 1. So that's just negative 4. Okay. That's exactly right. Yes. Right. Oh, okay. Remember, all it wanted us to do was go ahead and take a sum of these two evaluated functions. So Nathan's absolutely right. The negative 15 plus the negative 4 is now going to give me a negative 19. That's all we got. Okay. This is what we're calling composition of functions. We have an inner or an inside function and an outside function. We always work from the inside out. Okay. So before we go ahead and take a look at number 3, let's look at task 1 real fast. Let's go ahead and practice this idea again. Okay. We're given two functions. F is a quadratic, g is a linear, and I want to find f of g of negative 2. So do I need to plug negative 2 into f or g first? Okay, g, always start with the innermost function. Okay, so for this guy right here, that 1x is going to be replaced with negative 2. So let's see, g of negative 2 equals, so this will be 2 times x, 2 times negative 2, and then plus 1. So negative 4 plus 1. Negative 3. Perfect. Okay. But now here's what I was referring to a second ago. We took care of g of negative 2. We input the x value of negative 2. We got the output, the y value of negative 3, right? So this output now becomes the input, the next x value for that outside function. So I'm going to plug negative 3 into f. And that's all we're doing. I'm working straight through one function into the next. All right? So instead of 2x squared, I'm going to have 2 times negative 3 squared minus 3x. So minus 3 times negative 2, and then plus 2. Is everybody seeing what I'm doing? Okay, just like we started yesterday. Okay, yes, ma'am, Genevieve. Shouldn't this negative 2 be a negative 3? Did I make a mistake? Oh. See, that was just one of those teaching strategies again where I'm trying to make sure you're paying attention. I got to keep you guys on your toes. And there you go. Obviously, I could not fool Genevieve. There we go. All right. So let's take this one at a time. Negative 3 squared would give me 9 times 2. So we have 18. Negative 3 times negative 3. Okay, so 18 plus 9 plus 2. Okay, so that's going to give me 29. Yes. So that's the value of f of g of negative 2. Okay, is there any questions on where I got any of those values? Okay, we started with the negative 2. I plugged it into g. I got this answer of negative 3. And now I plug this into the very next function. Okay, 29. Okay. Now, the reason I wanted to go ahead and do another one was, again, just to get a little more practice for one that actually works. So let's go back up here now, take a look at number 3. Okay, so because of what I just said, you might already be thinking, well, maybe this one doesn't work, and let's see why. Remember, the output, the answer I get for the inside function has to be in the domain of the outside function. It has to belong to its domain, right? It has to be an x that's going to work. So what am I starting with here? P or G? What's my inside function? G, right? So I'm going to start with G, and I'm going to substitute what value? That negative 1. Okay, so G of negative 1. So this would be 1 minus 2x. So 1 minus 2 times negative 1. What's that going to give me? Okay, so 1 plus 2 is going to give me the 3, right? Now, let's just stop for a second. Okay, I would go ahead and plug this now into what? Into P. The value I get for G of negative 1, I would plug it right into the outside function, just like we did before. But here's the thing. Let's take a look at this guy for a second. P plus 2 over x minus 3. And this is part of what our exam is going to be. Okay, graphing a rational function. What value of x is going to make this guy 0? The denominator. 3, right? Okay. Would he have a hole? Why no hole? There you go. There's nothing that cancels. So one less thing to worry about. There's no hole. The only value of x that's going to make the denominator 0 is 3, right? So would everybody agree that I can say his domain is all reals except that x can't equal 3? Okay. Now, do you see where the problem is? What did we get for G of negative 1? We got 3. Remember, a composition is only going to work if the output, the answer I get inside, is in the domain of the outside function. Because this guy doesn't work, well, what do you think I can write? We could say undefined. Okay. Typically, we'll just go ahead and say no solution. It's very possible that a composition may not work for that reason. Okay. Right, Nathaniel? Right. Okay. All right. So let's see what else we have here. All right, so we took care. Now, this was actually part of something bigger. I just wanted to go ahead and use it as an example. So we've got f of g of negative 2. We got 29. We just talked about it, right? Okay, now we're going to try something different. Okay. Task 2, it says, okay, we're given these two functions, f and g. Find an equation for f of g of x. Okay. What it's asking you to do is find an equation that represents the composition. We're not plugging in a value. What we're going to do here, when it says find an equation, I'm going to take the equation for the inside function, and I'm going to substitute that into the other function. So I'm going to take this 2x plus 1, and everywhere I have an x, I'm going to replace it with this. So instead of plugging in a numerical value, we're plugging in an actual equation. Okay. So let's try that. Instead of 2x squared, I'm going to have 2 times 2x plus 1 squared. Minus 3x, so minus 3, again, times 2x plus 1. Okay. And then I still have the what? The plus 2. So when it's asking you to find an equation for the composition, you take the inside function and you substitute it into the other. And then now it's just back to good old algebra. We just need to go ahead and expand, distribute, combine my like terms, all that good stuff. Okay? So let's do this. Before we distribute the 2, we have to go ahead and expand this guy. Now, you can go ahead and write, 2x plus 1 times 2x plus 1 and go ahead and FOIL. What's that stand for? First, outside, inside, last. It just walks you through the steps, right? But if you're going to square a binomial, there is another way. Have I talked about the rhyme yet? All of the classes are kind of bleeding together, so I don't know. Okay, so the rhyme is, and it's not really a rhyme, it's just, it's one of those silly little things that can help you remember what to do. So, oh, someone up? Hey, on in, man. Okay. So it goes, you square the left, you square the right, you double the middle, and you got it right. Okay? And like I said, it's not really a rhyme because you're rhyming right with right. So maybe you want to do something else like double the middle, out of sight. Or, double the middle, math takes flight. Or, whatever does it for you. Okay? But let me go ahead and show you. The left term is the first term. That's what we're referring to. The second term would be your right. Okay, so let's try it. Square the left. What would I get if I squared 2x? 4x squared. Square the right. So 1 times 1 is 1. Now, here's the thing. When we say double the middle, that means I want to multiply the two terms together. So I want to multiply 2x times 1, and then we double that. So 2x times 1 times 2, what would that be? That would be 4x. Okay. Now, let me just go ahead and show you very quickly. If you were to expand it and say, okay, 2x plus 1, 2x plus 1, well, let's see. What's 2x times 2x? 4x squared. Okay. Now, it's the outside and the inside that you want to make sure is correct. What's 2x times 1? 2x. If I go inside, that gives me another 2x, and 2x plus 2x does give me 4x. See, that's why we double it. And then the last, well, that's 1 times 1. Okay. Now, if you like the rhyme, if you think that's pretty cool, I mean, who wouldn't, right? You know, please feel free to use it. If you like to go ahead and write it out in FOIL, please do that as well. Now, remember, this only works if you're multiplying a group by itself. If it's two different groups, you want to go with FOIL. Okay. So let's see. This one I still need to double, and then I'm not going to go ahead and distribute just yet, because I still have to distribute here anyway. Okay. So is everybody okay with what I've done? I've just expanded that binomial. Okay. Now somebody help me. What if I did distribute the 2 now? What would I get? 2 times 4x squared. 8x squared plus 8x. Okay, plus 2. Now across here we want to distribute this negative 3. Minus 6x. Minus 3. And then plus 2. There we go. So when you're finding an equation for the composition, it really just kind of reverts back to what you learned in Algebra 1, just your normal skills. Isn't that right, Nathaniel? You want to get a drink of water? Okay. Now all we got to do is just combine my like terms. Now nothing combines with the x squared, but how many x's would I have? There you go. 8x minus 6x will give me 2x. And plus 1. There we go. 4 minus 3. There we go. So this guy right here, he represents f of g of x. Okay. But you want to see something really cool? You remember when we plugged in f of g of negative 2? What did we get? We got 29, right? Okay. So this equation that we just got from the composition, let's go ahead and plug in negative 2 and see what happens. So 8 times negative 2 squared plus 2 times negative 2 plus 1. Okay. So what's a negative 2 squared? 4 times 8. Okay, 32 minus 4 plus 1. What does that give me? 29. So whether you go through the composition, hey. So whether you go through the composition where we plug a value in to both functions, or if you create an equation based on that composition, you should still be able to get the same answer. Okay. Cool, right? Definitely puts the fun back in function. You know what? I stand by that joke. That's golden. Okay. I should. One of these days when I retire, I'm going to write just Mr. West's big old book of bad jokes or whatever it is. If anybody were to see that in maybe Barnes & Noble or something, would you buy it? Yes? Who said no? There we go. All right. So let's practice a few of these. Okay. All right. So I've got 4 functions here, f, g, h, and p. Okay. F, g, h, and p. And A says, okay, find an equation for g of h of x. Now, we're finding an equation, so we're just working with like terms, we're distributing, we're doing all that good stuff. But here's my question. Will I take the equation for g and plug it into h, or h's equation into g? There you go. Always start with what's the innermost function. So because I have h of x, I'm going to take this, and I'm going to plug it in for every x in equation g. Okay. Andrea, you okay?
Yes.
All right. So let's see, g of h of x. So I'm going to start with g because I'm plugging into g. So 1 minus 2x becomes 1 minus 2, but now times that equation. 3 halves x minus 2. And sometimes it's just going to be, distribution. It really depends on what your function is. The reason the other one was larger was because we were plugging into a quadratic. Okay. Now let's see. We definitely have the 1 here. I need to multiply a negative 2 times a 3 halves x. What's that going to give me? Okay. Okay, so we're close. Now, when we're going to multiply integer by a fraction, like let's say I want to take negative 2 times 3 halves, pretend he's over 1. We just multiply straight across. So you were close. Yeah, it wouldn't be negative 6 fourths. It'd be negative 6 halves. Oh, what is 6 divided by 2? Yeah, negative 3. And if you're looking at this, remember, you can cancel on a diagonal. So either way, we're getting negative 3x. But now what's negative 2 times negative 2? Plus 4, okay? And the only thing I can combine now are going to be my constants. So it looks like I'm ending up with a linear function. Negative 3x plus 5. Okay. And there we go. Now, let me show you that again. I won't do this on all of them, but I do want you to go ahead and make the connection that this equation still works for the composition. Let's say I were to give you 4. Let's say I wanted you to evaluate g of h of 4. I'm just going to make that up, something up. So g of h of 4, right? Well, how would I start this problem? What would I do? Okay. What would I plug the 4 into? G or h? Okay. So I'm going to start with h. H of 4 would equal 3 halves times 4 minus 2, right? Okay. So let's say, just like we talked about, I want to multiply a fraction by that integer. So yeah, 12 halves would be 6. And what's 6 minus 2? 4. Okay. So I plugged in a 4, and I did get a 4 out, right? Now remember how the composition works. The output, the answer I get from the inside function, is now going to plug into the very next function, which is g. So now I want to find g of 4. Okay. So that would be 1 minus 2 times 4, right? Is everybody following along how I'm doing this? So what's 1 minus 8? What kind of 7? Negative 7. There we go. Would everybody agree? Now, doesn't this equation represent the composition, though? So if I plug in that 4 that I originally started with, what should it be giving me? Should be giving me negative 7. Well, let's see. Negative 3 times 4 plus 5. Will negative 12 plus 5 give me negative 7? Yes. Okay. That should work every time, as long as your algebra is correct. Okay. Anybody having trouble? Hey, Brandon, what can I do? This right here? Yeah, this is just kind of extra. This problem wasn't asking for that. I just really wanted you to see that the equation does work. Okay, so like on the next one, B, we're not going to do that. Okay, all right. So let's take a look at B. It says find an equation for g of f of x. So the equation itself is my answer. We're not looking for a value. So which equation am I going to plug into the other? Will I plug g into f or f into g? F into g, yes. So I'm going to take this quadratic and I'm going to plug it in here. Okay. So let's see. G of f of x, that would be 1 minus 2x, but instead of x, I'm going to plug in this guy. Negative x squared plus 3x minus 5. Okay. So all I have to do is distribute, combine my like terms. Okay. So what do I get if I distribute a negative 2? Okay, so that'd be plus 2x squared times 3x minus 6x and then plus 10. There we go. See, it's just really a review of Algebra 1. Okay, just your basic skills. What are my like terms? What are the only two I can combine? The 1 and the 10. Can't combine the x's, so I got to say 2x squared minus 6x plus 11. There's my function. Okay. How we doing? Okay, good. Good. All right, let's try C. Find an equation for f of g of x. Okay. How would I do this? There you go. I'm going to take this equation for g, but why is this one different? How many x's do I have? For each of those, I'm going to replace it with 1 minus 2x. Okay, and then we're just going to simplify. All right. So let me see that. Now, the only thing that's being replaced is the x. That negative in the squared is still going to be there. So this is going to end up being negative 1 minus 2x squared. See, there's your negative x squared plus 3x plus 3 times 1 minus 2x. And then we have minus 5. Okay. Is this making sense? Everybody's okay? Okay. All right, good. And this is an opportunity for us to go ahead and try expanding that binomial. Remember, we can't distribute the negative until I've expanded this guy. So try that left and the right rhyme, okay? Or if you want to write it out, and use FOIL, that's fine. But let's see if we can get that expanded. If somebody can tell me what that is. Square the left, you square the right, double the middle. That means multiply the two together and then double that. You got it right. Okay, so I'm going to go ahead and get this ready. I still have a negative to distribute, and then I'm not going to distribute this just yet. Okay. Okay, so square the left, you square the right, double the middle, we got it right. Anybody think they know what this trinomial should be? Okay, Leopold, what do you think? So 4x squared minus what? That is absolutely right. Perfect. See, we squared the left, we got the 1. We squared negative 2x, we got 4x squared. Double the middle, 1 times negative 2x times 2. That's where he got the negative 4x from. Perfect. How many people got that one right? Nice. Okay. Hands are going up. Good. All right, so now let's go ahead and distribute. So negative 4x squared plus 4x minus 1. So all I did was change those signs, right? What do I get if I distribute the 3? Okay, so that's plus 3 minus 6x, and then we have minus 5. Okay. How we doing? Okay. Now, can anybody tell me what my like terms are? We definitely won't combine x squared with anything. Okay, good. So we got that first term, 4x minus 6x minus 2x, and then minus 3, yeah. There you go. So it really depends on the functions you have. Some are going to go a lot faster than others. Okay. There we go. So let's try this one. It says find an equation for p of g of x. Okay. Who would want to come on up here and show me this? Who hasn't been up to the board? Brandon, have you been up to the board yet? I can't remember. I think you have, right? Now, you know what? I'm not going to turn down a volunteer. I'll go for it. Okay. So come on up here and show me how we do this. Okay, so p of g of x. So am I going to substitute p into g or g into p? G into p, okay. So I went ahead and pushed it a little too high.
Hey, you good? I got my paper.
Oh, you got your paper? Hey, there you go. Okay. Can't cancel. Can't cancel. Now, let me... Now, we can combine like terms, yes. Uh-huh. Still can't cancel. I know it's tempting. Okay. But that is actually it. That's as far as we can go. Now, we always want to ask ourselves, thank you very much, good job. We want to ask ourselves, is there any way that I could simplify or reduce, but we can't? And that's really a good point. Like, if I were to have, x over x plus 3, I'm just kind of making something up. Could I cancel the x's? Okay, we cannot do that. The reason is, whatever x represents, okay, see, this isn't really x right here. See, this is x plus 3. He's part of something larger. When you add or subtract to a term, you have to be able to look at the entire group. Now, if it were x plus 3 over x plus 3, absolutely. Common group factors are going to cancel. Okay, you can do that. I always kind of think about it like this. Like, Halloween is coming up, and what do a lot of people always get on Halloween? A lot of candy, right? Okay, so imagine you got a bunch of kids in front of you, and you were to walk in and say, okay, I'm going to give you 2 candy, but nobody else. What's going to happen? Yeah, those other kids are going to be like, where's my candy, man? Okay, where's my candy? So think about it like this. You have to look at the whole group. You'd have to include that 3. You can't just cross out the x's and leave the 3 there. Okay, so that's it. How we doing? Doing all right? Kind of, sort of? Okay, it'll just take a little bit of practice. Okay, which is, why you have your assignment. So as of now, you should have everything you need to go ahead and take a look at the homework assignment. I haven't forgotten about the quiz, and I think what we're going to do is move the quiz to tomorrow. That way we get the majority of this done. We come in tomorrow. Now, we're not done yet, okay, so don't put up, because we still have until 36. But tomorrow, we can come on in, probably even go ahead and do a few more problems off the notes, maybe even one off the homework. I can give you time in class to work on the assignments, and we'll also have time for the quiz. I think that's going to work out and really give everybody a bunch of practice time before the test on Monday. Now remember, just like Andrea asked, you can use your notes. Okay. Now here, these are just some properties that we have dealing with functions. Now these aren't composition of functions. Whatever you're given here, like it says to add, right? So I would do exactly what it's asking me. I would add the 2 equations together. If it's telling me to subtract, well, I would simply subtract them. I would multiply or I would divide. So you don't always have to substitute in as we have been, only if it's a composition. Okay, so let me give you an example of one of these. Okay, let me go ahead and take this right here, like this one. Is that a composition, or is that telling me to do something with the functions? Yeah, in fact, what's it telling me to do with f and g? Yeah, all it's doing is telling me to multiply, right? So here, I'm trying to remember what f was. Negative x squared plus 3x minus 5. Negative x squared plus 3x minus 5. And I think g of x was 1 minus 2x. There you go. Okay. So we can, elaborate on this tomorrow, but I'm just kind of wanting to touch on it today. Whatever operation you're provided, that's what you want to perform with these guys right here. So I'd want to take 1 minus 2x and multiply it by negative x squared plus 3x minus 5. Now remember, this is very, very different if it were given to me as a composition. If I were given g of f of x, what is it wanting me to do? There you go. Just like we were doing a few moments ago, this is where I would take the equation for f and I would plug it in everywhere we had an x for g. You only substitute the equation if it's a composition. Okay? So here that would be f times g of x. What if I were to give you this? What if I said f minus g of x? Would I substitute one into the other or simply subtract them? Simply subtract them. So f minus g of x, well, I would take negative x squared plus 3x minus 5, and then I'd want to subtract. And I always recommend when you're subtracting, put the expression in parentheses to help you remember you have to do what? Distribute the negative, because you're subtracting each of the terms. 1 minus 2x. Okay. That's the only thing. And it just comes down to our normal foundation skills. Adding and subtracting like terms, multiplying, all that good stuff. So in fact, let's go ahead and do this one. How do I multiply a binomial times a trinomial, though? Okay, what's what? Heard someone say something. Oh, heard someone say distribute. Who's saying it? Oh, there you go. Alizé. Okay. So let's distribute the 1. Well, this is going to be easy because what happens if I multiply anything by 1? Okay, so I'm going to start with negative x squared plus 3x minus 5, right? Taking care of the 1. Now I want to distribute that negative 2x. So let's see, what's negative 2x times negative x squared? Okay, so that's just 2x cubed, right? Remember, when you multiply the x's, you add the powers. Okay? What would negative 2x times 3x be? Negative 6x squared. And negative 2x times 5, or negative 5, plus 10x. Okay. And now we just go ahead and simplify the expressions. Let's see here. How many x, well, 2x cubed. Let me go ahead and start with him. Now, how many x squareds would I have? Negative, well, I heard negative 7, because we have negative 1x squared minus 6x squared. Okay. Taking care of both of those. How many single x's? Plus 13x. And then are we missing anything? Don't forget about that minus 5. Okay. Is this making sense? Okay. Even this one right here, if I were to give you f minus g of x, okay, well, what's going to happen when I distribute a negative 1? What's it going to change about those terms? Yeah, it's just going to flip their signs. So negative x squared plus 3x minus 5, this would be minus 1 plus 2x. Okay. And let's see, can anybody tell me what my final expression would be? Is Brandon right? That's it. That's all there is to it. How are we doing with compositions? Are we feeling pretty good? Are we feeling okay? Okay. Does everybody still have a copy of the homework? Okay, now the homework we will go ahead and turn in tomorrow. So I'll probably go ahead and do 1 or 2 more problems as a review. I'll give you some time in class to work on that. We'll grade it, and then we'll finish up with that quiz over rational functions. Good, good, good. Thank you so much, guys. You did a great job today.